Feasibility is certainly important because, again, most often people have a new idea to approach a particular problem, and the product is almost certain to fail if whatever that proposed solution is doesn't actually solve the problem. So, one of the first things we tackle is a proof of concept of the core concept that product is built around. The proof of concept may not be battery powered, even though the end product should be. It may not connect to the cloud, even though the end product is going to connect to the cloud. It may be bigger than the final product. It certainly will be in different packaging or something like that. But the idea is to develop an iteration of the prototype that will test the core concept at the heart of whatever the product is and validate that it will solve the core problem that it needs to solve. For instance, if I want to build a pet tracking device, so this is something that my dog is going to wear around his neck on his collar, and I will have a handheld device that can track it. So if he gets lost, I can track him down. There are a lot of pieces of that, but the core functionality that we need to confirm is, can I have a handheld device that tracks a remote device? And so a proof of concept of that would be something that involves a couple of radio parts and some firmware that would accomplish that core task of tracking this remote tag. Again, maybe they wouldn't be battery powered. It certainly might not be the size of something that you would put onto your pet. It wouldn't be in the packaging or anything like that, but it would test that core function, that core feature, to make sure that, yes, we can make it work. And it even works if he's on the other side of the block wall or other types of things we would want to test to ensure that core problem can be solved. And so that's really the first feasibility test, is in that proof of concept. The next step is to take that and then start adding other aspects that will be part of the finished product. And we typically try to approach it by addressing the highest risk things first. We try and do an analysis and look at what the features are. Maybe something like, if in my pet tracker device, range is an identified risk factor. And so we would work to build, in addition to a proof of concept to show that will just work, we would also try and figure out, okay, what is the range on this? If it's only good for 20 feet, that's probably not as helpful as 200 feet. And so figuring out the range might mean a design iteration.